Hey everyone, welcome back to the tutorials on computer aided machine drawing. So in today's session I am going to teach you how to do the assembly of screw jack. So let's get in. Part B, assembly drawing 3D model of simple machine parts. The first one is screw jack bottle type. So this is the screw jack of bottle type. The drawing has been given. So here you can see in this figure, this is the assembled of screw jack. So this is the exploded view of screw jack. So all the parts are named here. So this is body, this is nut, this is screw, and this is tommy bar, this is washer, this is cup, and this is screw. So this is the exploded view of that. So here they have given drawings of individual components. So by using these drawings I want to develop the individual components in the part modeling. So once we have completed the part modeling of all the components, then we need to go for the assembly workbench and we need to call the individual components. By using the constraints, you need to assemble the components with respect to the body. So once assembly is completed, then again we move on to the drawing workbench. So we will create the drawing from this 3D part. So finally I want to show the cut section view like this, and this is the top view and this is the side view, and I want to name all the parts by using balloons, and also I want to list this bill of materials. So this is the complete drawing of a screw jack. So let's begin with the software. Okay, select front plane, sketch. First draw the reference lines like this. Okay, next zoom out. So first I will draw the sketch like this. So now we'll start giving the dimension for this. So this dimension is required. Next, this dimension is required. Next, to here it is required. Next, this is required. So next, this is required. This is required. So next, finally height. So this is required. This is required. This is required. So now let's edit all the dimensions. So now here to here it is 50, half of this. So this is 50, and from here to here it is 70, 50, 70, and this is 20, and this is 50. This is 70, this is 50, this is 20, this is 50, this is 180, 185. Next, this is 40, and next 50, 70, 25, 35. So this is 25, this is 35. Next, this one 67 divided by 2. So this is 67 divided by 2. So next, height I was given. So hope I have given all the dimension. Now select these two lines and make it parallel. Yeah, make it parallel. So now go for smart dimension, select these two and give it as 10 mm. So now you can see the sketch. Okay, so the entire sketch is black in color except this. So this I have not given, so specify. So this is given as 3. So you can see the entire sketch is in black color, means it is fully defined. So now I can exit this workbench and I can revolve this. So go for features and revolve this. So it is asking for axis for revolution. So this is the axis for revolution, and yeah, this is the sketch you need to select. So it is completely 360 degree I want, so you can complete this. Okay, so this is the body of screw jack. So next, here it is round for 8 mm. So here also some finishing operations you have to do. So go for fillet, you select this, radius 8. So next, zoom this. So again go for fillet, you select this, you just give minimum 3 because its dimension is not given, it is just a finishing operation, so I give it as 3 mm. So 3 mm, it is done. So you can check the front view of it. Okay, next, internal threads has to be cut over here. So due to the graphical cards and the processor I have, I can't able to create the internal threads because system will be very slow. So I will just going to represent it as a internal threads. So just click over here, select this and click on the appearances here. Again in the appearances, just click on miscellaneous. Again you click on pattern, double click on pattern. So here you can see the pattern for screw thread. Okay, so just double click on this, so it will appear as threaded. Okay, so due to the graphical card I have and the processor I have, I can't able to create the internal threads because it will become very slow. So this is enough. I am just going to represent it as internal threads here. So you can see the internal threads, you can zoom in and you can see it as an internal thread. Okay, so this is enough for me now. So now let me save this component. So file, save as. So first I will create one folder, screw jack. So this is the body component. Okay, save this as body, save. So next, second component is screw spindle. So go for new part. Okay, so next I will choose the top plane, sketch, change this to mmgs. So this is the screw spindle. So let me begin from this. Okay, first I am going to create this rod and then I am going to create this feature. So this radius is 38. Exit. Next, its dimension is 240 minus 83. So mid plane, 240 minus 83. Okay, next I will select this face, sketch, Control 8. Again I will draw one circle. So its diameter is 65 and its length is 83. So this is 65 and 83. So next again sketch on this face, control 8. So here 22 diameter, 12 thickness. So 22 12. Okay, so next, so I will create this chamfer now. Okay, so this chamfer here, so its dimension is 10 into 45 degree. So let me choose chamfer. So it is asking for angle and distance or distance and distance. So two options we have here. So here angle and distance is given, so I will be selecting this angle and distance. So select this and also select this. So it is 10 and 45. Okay. Okay, next, here I have through hole of dia 12 mm. So for that I will select one plane, front plane, sketch, control 8, circle. So dia 12. Next, so this is at a distance 35 mm from the bottom, 35 mm from the bottom. So from here to center it is 35. So now exit, extrude cut through all both. Yes, got it. So next I am going to create this threaded hole to insert the screw. So its dimension is M12 and its depth is 25. So select this hole wizard, go for position, select the face and click on the center. Next go for type, select this hole. So change this for ANSI metric, change this to screw clearances, and this should be M12 and its depth is 25. Okay, its depth is 25 and click OK. So you can see that hole here. Okay, so this is to insert the screw. You can see this clearly. Okay, so change this wireframe. So next, so you make this as chamfer here. So go for fillet, not chamfer. So select this and use just a minimum 3. So 3 is sufficient. So this is fine. Next, again I'm not going to cut the external threads on this rod because of issue with the graphical cards and the processor I have. I'm just going to make this appearance as square threads. So same procedure I will follow. So just select this, go for appearances, again pattern, double click on screw thread. So this will look like a square thread now. So I think I have completed this hole. Yes, 12, 240, 20, 37. So this dimension I have given as 83 from here to here, but it is 83 minus 12 and this is 12. So this I have to change. So second one I think. So click on box, extrude, edit feature. So it is 83 minus 12. Okay, so now it is fine. So save this, save as screw spindle, click OK. So next, so let me develop this nut now. So this is the top view and this is the front view given. So this is the hatching part. So I am going to create this sketch, and this is the axis for revolution, and I am going to develop this nut. So new part, okay. So select the front plane, sketch, draw the reference line, select the line. So this hatchet part I am going to create now. Profile, okay. So now give the dimension for this. So here to here it is 25, this is 10 and this is 10, and again this is also 25 and this is 45. Sorry, so this is 10, this is 10. So next, so this is 45, height is also 45. So from here to here 45, and height is also 45. So this internal diameter, so here it is given, so 38 into 7. This is the specification of a thread, square thread, 38 mm into 7 mm is the pitch. So as I said, we are not going to develop these threads. Instead of this, I am just going to make this appearance as a screw thread. So its dimension is 38, means 19. So from here to here it is 19. So next, exit this. So now we'll create this fourth part, cup. So this is the front view and this is the top view. So let's create this geometry first, the hatching part. So select front plane, sketch, center lines, so this profile I want to create now. So line, so now dimensions. So this is 45, this is 22.5, so half of that, from here to here, 45 divided by 2, from here to here, 22.5 divided by 2. So next, see here to here, 65 divided by 2, and this is 12. Here to here, 65 divided by 2. So this is 12 and this is 42. So next, select these two lines and make it parallel. So next, this distance is 6. So sketch is fully defined. You can exit this workbench, revolve, select this as an axis, 360 degree. Okay. So next, here we have cutout, radius 5 on all 4 directions. So for that, you select the plane, front plane, Control 8, circle, so this is radius 5, diameter 10. So exit, extrude cut here through all both. So next, select right plane, sketch, Control 8, circle, diameter 10, exit, extrude cut through all both. Okay, so cup is ready. So now you can save this, save as cup. So first I am going to create this profile and I am going to revolve this around this axis to get a screw. Select front plane, sketch. First I will draw the reference lines. Next, dimension. So this is M12, means half of it is 6. Next, this is 6 and this is 24 and this is 27. Smart dimension. So this is 6. This is 6. This is 12, and from here to here it is 27. So here to here this is 27. Correct? Yes. Next, this angle is 45 degree. So for that I will draw one reference line. Next, smart dimension, this line to here, so this is 45 degree. Okay, so not required 45 degree constraint. Next, so this is 6, 6, 24, 45 degree and 27. Okay, so exit this, revolve this as the axis, so angle of rotation is 360 degree. Click OK. So next, select any one of the plane, sketch, Control 8. So draw one reference line. Next, go for corner rectangle. So create one rectangle like this. Select this line and this line, make it collinear. Next, so this is 2.4, so this is 2.4. So select the drawing and move this. Okay, zoom it. Now make it symmetry. So select this line and this axis, make it symmetric. So exit, extrude cut through all both. So next, this has to be threaded. So go for appearances, miscellaneous, pattern. So double click on screw thread. So save this. Save this as screw. Save. Next. New part. Okay. So now let us create this Tommy bar. So first I am going to create this rod of dia 12 and next I am going to extrude this rod of dia 20. So top plane, sketch, circle, so dia 12, exit, extrude. So this is 62. Okay, so next select this face, sketch, normal, next dia 20. So this is 275 minus 62. 275 minus 62. Okay. So next go for chamfer. So you select this. So any dimension less than 10 you specify. So 7. Angle is 45. Okay. Yeah, enough. And again go for chamfer, select this, and this is also minimum. Okay, so give it 3, so it looks good. So next here go for fillet and select this. So radius as 10, as dia is 20, so radius as 10. Okay, so here knurling is given. So because of graphical card issue I can't able to do the knurling over here. It is VZ, and if it is required I will show it in the next video. So save this. Tommy bar. So next new part. Okay, so next is washer. Okay, so this is the washer. So I'm going to create this hatching part. Now specify the dimensions. So this is 45 degree and this diameter is 12 and this is 35. So this is 35 divided by 2. So this is 6. So next, so this angle is 45 degree from here to here and this is 24. So this is 12 and next, so total height is 8. So this angle is 45. This angle is 45. So you can exit this, revolve, select this as the axis. So this is the washer. Next, go for chamfer. You select this edge. So specify 5.5 means 5, 6, 7, 8, 2.5. Okay, so this is the washer. So here you can see 8 and 5.5 is given, so remaining is 2.5. So it is 2.5 and angle is 45 degree for that chamfer. Okay, so if you want you can see the front view. Yeah, looks correct. Okay, so save as washer. So I think we have done with all the components: body, nut, cup, screw, tummy bar and washer, special washer. So now I want to assemble all the components to get a screw jack like this. So now let us start with the assembly. So new, go for assembly workbench, click OK. So this is the assembly workbench. So now first I am going to insert the components. So in the assembly workbench, first I am going to insert the components. So click on this insert and here you can click on browse. So wherever you have saved all the components, you go to that folder and you first select body component, click open. So you keep it here. So whenever we call the first component in an assembly, so the first component will be automatically fixed. So you don't need to define that. So automatically it will be fixed. So next I want to insert the second component. So second component is cup. Sorry, second component is nut. Yeah. So now select on mate. So first select this cylindrical surface and this cylindrical surface. So click OK. So now we just move this up, rotate this, select this face or this face. Okay, so if you want to lock the rotation, you can lock the rotation. So in this case it is not required, so I'm just going to click OK. Next, you select the front plane. First, this is the assembly workbench, and we have three planes for this workbench, that is front plane, top plane and right plane. And for every component we are inserting, same that component is also having three planes, front plane, top plane and right plane. For the perfect assembly, I want to coincide all the planes with respect to the assembly workbench planes. So now I am selecting this front plane of assembly workbench. So it is a bit slow. So you select the front plane. Next, you can expand this, and here you can see the front plane for this body component. Okay, so just click OK. So both will get coincide. Just rotate the direction and click OK. So now for time being I am going to move this. I'm not going to constrain any rotation here. I'm just going to move this. Later I can fix it. So next, again insert components, browse. So it is cup now, cup, open. So rotate this. Here it is, mate. Select this. And you select this. Click OK. And next, this with this face. Click OK. Next, call the washer. Insert, browse, special washer, open. So we keep it here. Next, mate. Select this cylinder, this with this. Okay, so next, this face on this face. Okay, next, insert screw. So screw, open, mate. So this cylinder with this cylinder. Okay, so next, this face with this face. Okay, next, insert Tommy bar, browse, Tommy bar. Okay, mate. So this cylinder with this cylinder. Okay, so just move this out. Next, you zoom this, so you select the edge point. Yes, this with this. So here this height is given, it is not completely closed here. So to do that, I am just going to give the reference for that. So this face to this face, so this face. Okay, so I am going to specify some distance for it. Okay, so it is showing as 44 and I will make it as 50, so it looks good. So change this. Oh, yes, so plain white, you can see. Next you just check for the front view. So this view, you can see here, this Tommy bar is not adjusted perpendicularly, so that is the problem. So in order to make this perpendicular, so I'm going to make the reference planes of this body as well as Tommy bar. So I'm selecting one of the plane for your body, so right plane. So you can see the right plane. I'm going to coincide this plane with the Tommy bar right plane, so that you will get exactly the perpendicular view. So Tommy bar, so this is the right plane. So okay, so now you can see, so both the planes are coincide. Click OK. So now you can check for the front view. See, so this is the one mistake students will do. So they will not coincide the planes of this Tommy bar as well as the body. So this is required, and only you will get the view in drawings perpendicularly. So next, save this assembly, save as screw jack assembly. So next, drawing, new drawing. Okay, so browse A4 landscape, open. So uncheck this, click OK. So next, screw jack, double click, keep it here, again keep it here. So I want these views. Okay, so I want these views now. So go back to the drawing. So this is coming in this direction. So to change that, to change this, just go back to the assembly. So expand this mates. So the last one we have created, so that I need to delete. So delete, yes. Again go for mate, expand this. So body front plane and Tommy bar front plane. So Tommy bar front plane. So I'm going to coincide this. So click OK. So now you can check for the view. So this is fine. Okay, so save and go back to the drawing. So it is updated automatically. So you just click on this. You can use the scale. Let me check for 1:5. So it looks good. So change it for 1:2. So it is large. So better 1:5. Use this hidden lines on. Okay. So to take out the section, go for section view. So here you can go for half section and you can select this one. Okay, so this is right side up. So exactly you need to place it the center, then only you will get perfect sectional view. Yeah, this is the center. So I'm just clicking it here, click OK. So flip direction, so just place it here. So later you can delete this. Yes, you can move this up. Still, if you want to increase the size, you can go for custom scale. So no, 1:5. So just select the drawing, go for use custom scale. So here the first one, user defined, and change this for 1:3. So it's good. We have this 1:3. Click OK. So but still I want to insert bill of materials, so this is good to have 1:5 only. So I want this right side view, so projected view. So you click on this and you click here. Okay, so click OK, and again select this drawing, make it visible. So according to this, yeah, this looks good. Next, if you want, you can just separate the planes like this for side view. Next, model view. If you want isometric view, double click on this and choose isometric view, and you can place the isometric view over here, and you can fill in the solid over here for this. So next important is generate the bill of materials. So go for annotation. So in tables, bill of materials, and you select the isometric drawing and click OK. So you can place this somewhere here. Okay, space is constrained, so just click here. Later you can edit this. So just move this. So you can fit it like this. So later you can write the description like so what is the material made up of, body made up of, nut made up of, you can type it here. So next, go for balloon. Okay, so you should number the part, like first part is body, so you should show which is the first part here. So this is 1, and next click on this is 7th one, and this is 4th, and this is 3rd one, and this is 2nd one. You can zoom this, you can show for this. This is 5th, 6th one, and also you can select this one for washer. So you can see 1, 2, 3, 4, 5, 6 and 7. So all the parts are listed in this bill of materials, and some dimensions you have to show here, like what are the dimensions you can see in this drawing. You should specify all the dimensions here. So that's all for today's class. You have completed the assembly of screw jack. Finally you can save this, save the drawing, save, and you can save this as PDF, and you can take a printout of it and you can submit to the teacher. So thank you all, see you in the next video.